Oh, hey guys, I didn't know I was recording yet. Alright, today we are talking about density. We're talking about density. This thing right here, it works by density. I don't know if you can see this. You got this nice blue layer, looks like the ocean. Got this nice clear layer, it's actually a liquid there, and some boats floating on it. Woo! Let you see this in class if you come in. Alright? Booyah! So, today we are talking about density. Density is a really important topic, and we'll spend a lot of time on it in class with hopefully a lot of fun exercises that we'll do and experiments and challenges coming up. So make sure you're writing down stuff, and here we go. So let's look at these two boxes here. Okay, so let's look at the two boxes here on the screen, and as always, let me pull up my pen. I always seem to forget to do that. Alright, so the following boxes, they're the exact same volume. So you have two boxes, same volume. If the mass of each of these red balls is the same, which box would have more mass? So if I put these both on a balance, which one would have more mass? Box A or box B? Box A or box B? And hopefully you said, well, box A would have more mass. Now, why would it have more mass? Once again, here is A and here is B. Well, plain and simply, it's got more stuff in it. Alright? Now, here's a technical definition. The box that has more balls has more mass per unit volume. Ugh, per unit volume. We'll explain what that means in just a second. Basically, it's got more stuff in it, so you get the same volume. If you ever move somebody and have boxes, think of this, you know, box with a whole bunch of stuff, and they're sealed, box with just very little stuff. Which one's heavier? Alright? So, moving right along. So, density calculates the mass per unit volume. Once again, here's that per unit volume. What does that mean? Well, let's look at the formula. Density equals, so make sure you're writing this down, this is super important. Density equals, so the D is density, the M is mass, and the V down here, if you haven't guessed it, is volume. Okay, so density calculates the mass per unit volume. All that means is mass divided by volume. Okay, mass divided by volume. You've seen something like this before. Anytime you're on the road, you might see something that says 45 mph. What does that stand for? Miles per hour. Miles per hour. So all this is mass per volume. That's what it means by unit volume. So density formula, make sure you get it down. Let's continue on. So to calculate density, you need two things. Yes, that's right, there's two. Thing number one, find the mass in grams. Okay, so whatever item you have, you need to find the mass of it. And how do we find the mass of something? Well, we put it on a balance. Right? We put it on a balance. So make sure you find the mass in grams. Ooh, let's underline that one. In grams, big time importance. Okay? There it is, using a balance. And the second thing, we're going to find the volume. So to find density, you need to have mass and you need to have volume. Two ways to write volume, either in centimeters cubed or in milliliters. Okay? So in the end, you should have a unit that has either centimeters cubed or milliliters in it. How do we calculate volume? Well, there's a number of ways to do it. First thing, if I had a box, oh, you're about to see Mr. McCoy's 3D drawings. You're going to love them. They're so good. Look at this. Booyah. Looks like it's coming right at you. Alright, so if you have a box and I want to find the volume of a box, what do? Well, you do length times width times height, right? That's the volume of a cube, right, or a box. So if you have something that's box-like, cube-like, you're going to take a ruler, length times width times height. And when you do that, length will be in centimeters, width will be in centimeters, height will be in centimeters, and when you multiply them all together, guess what you get? Centimeters cubed. Centimeters cubed. So that's where the centimeters cubed comes from. Alright? If you have a liquid, got some water here. Not much. If you have a liquid, alright, now I want to know the volume of it. Just pour it into a graduated cylinder. Pour into a graduated cylinder. Now there's another object. Well, what happens if you have an object that's just kind of weird? How do you get the volume of a pen? Well, you do something called water displacement. Okay, you do something called water displacement. You have a little picture here. What you do is you put some water, right, into a graduated cylinder and measure the volume. Measure the volume. Okay, so let's say maybe that's 30 milliliters. And then what you're going to do, and let me change pen colors here so I can make some water. Let's get a nice blue color here, and maybe that'll match. Okay, so then what you do is you add some more water. I'm sorry, you don't add water at all. Erase that. I'm just drawing water. Add the objects, the irregular shaped objects, okay, to the 30 milliliters, and all of a sudden, what will happen to the volume? Well, it goes up, right? So the volume goes up when the item goes in it. Well, what added volume to that? So let's say this now says, we'll pretend it says 50 milliliters. Okay, so it went from 30 to 50. Well, if this was the ball that was put in there, well, what's your volume? Well, you went up to 50 milliliters. You started at 30 milliliters. You didn't add any more water. Okay, don't add any more water. You just added the object to it. The water level went up. So you just subtract those two numbers and you get the volume of your item you added. Alright, makes sense? So that's called water displacement. So what are units for density? Well, if you're using a ruler to measure your volume, you do it in grams per centimeter cubed. If you're using a graduated cylinder, grams per milliliter. And don't forget, 1 milliliter is equal to 1 centimeter cubed. Okay, so if you had 30 milliliters, it's also 30 centimeters cubed. Alright, mass and volume are directly proportional. Ooh, big word there. Hopefully you've used it before. Directly proportional. Okay, directly proportional. That means as volume increases, mass increases. As one goes up, the other one goes up. So, if we were to look at a graph, the graph would look something like this. As the mass increases, the volume increases. Now, just a little side note here. If you were looking at a graph of density, and this is going to be a little hard to draw straight, I'll try my best. If it's a really small density, your graph, your graph might be something like this. Pretend that's a straight line. If it's a really big density, your graph would have a much bigger slope. Oops, that's kind of straight, right? Your graph would have a much bigger slope. So, the bigger the slope here, the bigger your density. What happens if we mix a whole bunch of liquids together? Well, if they don't dissolve in each other, like if you mix water, gasoline, and mercury, they don't really like each other, okay, and you shake it up and you let them settle, what would happen? What would it look like? Well, since they don't dissolve in each other, and they have different densities, here are their densities. You have water, gasoline, and mercury. So you're shaking it up, put it down, let it sit. Come back 5 minutes later. What would it look like? Well, it would look something like this, where your gasoline would be on top, water in the middle, and mercury on the bottom. If you haven't learned this before, it's okay, you're learning it now. The largest density actually goes to the bottom of the bottle. So we have mercury down here. So your largest densities always go to the bottom. Your middle-sized density, water's in the middle. And gasoline, your smallest density, always goes to the top. So if you ever wondered why things float in the water, okay, well, water has a density of 1.00. This is super important. If you will, please, there's stars. Please write this down. Start, underline it, circle it. You need to know it. So water's density is 1.00 grams per milliliter. Okay? If you put something in water that's got a density larger than that, it sinks. You got something that has a density lower than that, it floats. All right? Air has density. If you ever want to know why like a helium balloon floats in the air, well, guess what? The density of the helium balloon is lower than the density of the air. So the helium balloon, rises, goes to the top. Air's got a bigger density, further down. And this thing right here is called a density column. You'll see a density column in class. Okay, we'll make some. So, density column. Actually, you've already seen a density column, technically. This right here is a density column. Alright, we're going to solve lots of density problems in class. None right now, though, but lots of them in class. First thing you do, write down the formula. So here's your steps. Second thing you do, write down what you are given, including units. Units are very, 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 very important. If I tell you something is 13.0 grams, you better write the G. If I tell you something is 12.0 centimeters cubed, please write that, centimeters cubed. Next thing, make sure your units don't have to convert. Okay, make sure you don't have to convert units. Sometimes I'll say, what's the density in kilograms per centimeter cubed? Okay, and we'll practice some of those in class and learn how to convert those. And finally, you solve, making sure you write down your units at the end. So, write down your formula. You should write down every time D equals M over V. I want to see all of your work. Okay? Step 2, write down your givens with units. So here's our mass. So you might want to say mass equals. Here's our volume. Make sure you don't have to convert units. If you do, we'll show those in class. And then solve. Fantastic. That's density. See you in class.